In this video, we will talk about the usage of the M5 Stick C, an IoT device, as an alternative to mobile phones for a low-cost quizzing system. This project will mainly look at message queuing telemetry transport and Bluetooth Low Energy as the main communication methods in which the IoT device will communicate for the quiz system. Current classroom interaction solutions rely on students having a smartphone as well as an active internet connection. However, there are still areas in the world in which the smartphone permutation is not that high yet. As such, we aim to create a low-cost IoT solution to counteract the high cost of having the students buy a mobile phone while still providing them a similar experience as to those of the current classroom interaction solutions. The main features and benefits would be a greatly reduced cost for students who currently do not own a smartphone, as well as not needing to have an active internet connection in order to utilize this system. Next, I will talk about the hardware that we use for this project. We use the M5 Stick C+, which is the client that the students will utilize to press buttons to indicate their responses to the classroom interaction system, a Raspberry Pi that is used as the server and collates all these responses, and a laptop that is used to interface with the Raspberry Pi. For the software, we utilize Mosquitto's MQTT broker, Python, utilizing the following libraries: Tahoe MQTT, and Blick for Bluetooth Low Energy communications. Outside of that, we also utilize the Arduino MQTT library. Next, I will show you how our setup is connected physically. So the Raspberry Pi is connected directly to a wall socket. Turn it on, and then in order to connect it, so we'll connect to it via SSH on the computer. Once it has connected to the Wi-Fi hotspot on my own computer. Sick. This is gonna take a while, isn't it?
What happened?
Basically it's starting up.
Oh.
Yeah. Okay, so then now this is fine, and then we can log in. Okay, so once here we can cd into the right directory. Stop the default Mosquitto service so we can run ours with the verbose output. And then on this side you can see that once I start up the user interface, the MQTT client will get a setup from it. Then for each individual client, once they are turned on, the broker will get a message as well. I haven't get the right number there. I think I did. Yes. Okay. Then you can just stop the recording here. To better illustrate how the MQTT clients are connected, this is a diagram which shows the connections between them. The Raspberry Pi server is listening for the following topics, which are status, responses, and audio. The status is used to indicate to the Raspberry Pi whether the Stick C is still connected to the MQTT broker, as when it disconnects, the broker which has received the last view from the M5 Stick C Plus will declare that it is it is no longer online and update the Raspberry Pi server so that the server can keep track of the number of students who are currently connected to the system. In the case of Bluetooth Low Energy, the M5 Stick C Plus connects directly to the Raspberry Pi server. Then The Raspberry Pi server will set up notifications to listen to the responses to changes in the response characteristics as well as the audio characteristics of the M5 Stick C+. In doing so, the Raspberry Pi is able to pick up when the responses on the M5 Stick C+ has changed and is able to act on it. To check whether a Bluetooth device is connected, there is a timeout that is associated with it, and if a device fails to send a keep alive message within a 4-second timeout, it will then be considered disconnected. So at the start, before I run the program, the folder is empty. Okay, so once we run the program, okay, you can see that a connection has started up, and then individually when we turn on the clients, once it's connected, you can see that it's indicated on the program itself. So the teacher can keep track of whether the students in their class is connected. So over here we have two M5 sticks that are using the screen with text in order to indicate what's going on. However, that is a bit battery intensive, so for the final product most likely it will be using just LEDs to indicate the current status of the M5 stick. So at any point during the system is running, students can press the button in order to react and raise their hands, for example, and then if they press the other button, they can put down their hands if their query has been answered throughout the course of the lecture naturally, or whether the teacher has clarified their question. Okay, so let's say when the quiz system wants to get started, the teacher can just hit the next key and start the quiz. So at any point, the students can just press, and then it will show up, indicate on the end. Okay, so once the times is up, the answer will be displayed, and then the number of students for each answer will be selected. So after progressing, so let's say we have a second one, we have a second MCQ as well here, and you can see that all four of it has done it. Okay, so now for the last thing to demonstrate, we have a way of answering open-ended question by making use of the microphone in the M5 stick. So in this case, once we press next, the students can press the middle mouse button, and then it will start an audio recording that will record whatever they are saying currently. So once the message is recorded for 5 seconds, it will automatically be sent to the question server. And so once this is done, okay, I'm now going to quit it, and then you can see that now there's the audio files for each of the students' audio recording. So over here, I'm just going to copy the file over to my computer to play it out loud. Okay, and wait, sorry, book question 2. Okay, and then you can hear the audio being played here. It's a bit soft. Okay, and that comes to the end of our demonstration. In summary, through the use of this low-cost IoT quiz system, we hope to improve classroom interactivity and allow those who either forget their smartphones or are unable to afford one still be able to participate in classroom interactions. This quiz system can hopefully be extended to create an app for smartphones to interact with the system without any additional upgrades. Thank you.